Hello, in this lecture I'm gonna talk about Fibonacci series and come up with a formula and derive that formula, why that formula is giving the kth element in the Fibonacci series. First I want to write down the Fibonacci series 0, 1, 1, 2, 3, 5, 8. So basically the way Fibonacci series works is you basically add these two numbers, then it gives a subsequent number, then you add these two numbers, then it gives that subsequent number, and so forth, so on and so forth. Say for example, if you take 8, so basically add these two numbers and you get 8. So this is okay if you're talking about a small set of Fibonacci series. But let us say if you want to get the 10th element, so basically it is going to grow exponentially, and it is going to be very difficult to find the 10th element of the Fibonacci series. So there is a formula available which will give the kth element in the Fibonacci series. So the formula is fk, this is the kth element, is equal to 1 by square root of phi 1 plus square root of phi by 2 to the power k minus 1 minus square root of phi by 2 to the power k. So basically this is a very simple formula. Maybe it is surprising for some of the folks to see that this formula can give the kth element. Even to validate it, it is going to be a little complicated just to apply directly, because if, say for example, if I have to find the third element here, then I have to find the cubic of this. But if you look into the element within this, it is basically a constant. This is basically a constant, so we can calculate this instead of just finding the cubic or the kth power to this. So basically this is 1 by square root of 1 over square root of phi into C1k minus C2k. When C to the power k, C1 to the power k, C2 to the power k. So C1 is nothing but this, and C2 is nothing but this. And when say k becomes very large, say when k goes to infinity, so this number is going to be very small. So if the k is very large, the kth element of Fibonacci series is approximately equal to 1 by square root of 1 over square root of phi into C1 to the power k. And again, C1 is a constant. So this looks very simple formula to get the kth element. So I'm going to stepwise derive this formula. So I will write down this formula here, so we will know what it is. Just to recollect, fk is equal to 1 over square root of phi C1 to the power k, C2 to the power k, and C1 is 1 plus square root of phi by 2, and C2 is equal to 1 minus square root of phi by 2. And when k is large, and Fibonacci, the kth element of the Fibonacci is C1 to the power k by square root of phi. When k is big, large, or approaches infinity. So that is basically the formula. So what I'm going to do here is to stepwise derive that formula and tell you how we can come to that formula doing a stepwise derivation. So here the Fibonacci series, let me write down one more time, 1, 2, 3, 5, 8. So if you watch closely, again I mentioned it how the subsequent element in the Fibonacci series is derived, right? So let's say if you take fk plus 2, which is say this one, so this is fk1 this element plus fk. So then fk plus 1 is equal to fk plus 1. Right, the same, 1 is equal to 1. So this can be written in a matrix form. So fk plus 2, k plus 1, this is the matrix. So we can say 1, 1, 1, 0, fk plus 1, fk. So basically we are writing this equation in a matrix form. Let's call this is uk, this is matrix A, so maybe you should say uk plus 1, so this is uk. So the uk plus 1 is equal to a uk. Maybe I'll write down this just to recall. uk plus 1 is equal to a uk, and again I will write down the matrix 1, 1, 1, 0. Okay. Maybe I should write down this too, because fk plus 2 is equal to fk plus 1 plus fk, and okay, we don't need to have this, but fk plus 1. Okay. Let's take uk plus 1 is equal to a uk. So when let's say k is equal to 0, so that means u1 is equal to a u0. So what is u0? Which is nothing but the first elements, right? So if you take say, and that's why I want to keep this, because you may think it should be 0, 1, but the way we wrote the matrix is k plus 2 and k plus 1 in the second element in this column space. So the 1 is going to be here. So this is the first element, this is the second element for the u0. So this is the first element. So this is u0. So maybe I should keep that also here. 1, 0. So let's say, okay, now u2 is a u1. So we know what is u1, which is a u0, which is equal to a square u0. So u3 is equal to a u3, so u2. So